Good morning, all. Welcome to the lecture of complex analysis. I am audible.
Yes, sir.
Okay, thank you. Okay, so in last lecture we have seen what is the maximum modulus, and after that we have seen maximum modulus theorem. What is the statement of maximum modulus theorem? Yes. What is the maximum modulus theorem?
If there exists a point in region such that modulus of function is less than or equal to modulus of f of a, then f must be constant function.
Then f must be a constant function, and any complex valued function f is said to have a maximum modulus at a point a in G if modulus of f of z is less equal by modulus of f of a for each value of a belonging to our set G. Okay, so that one is nothing but definition of maximum modulus. That is the maximum value of a given function at a some point a in G, and the maximum modulus theorem is nothing but if we have defined one function f from G to C, and there is a point a in G for which modulus of f of z is less equal by modulus of f of a for z belonging to G, then f must be a constant function. Okay, now today we have to see the index of a curve with respect to a point A. Let us see the definition. Index of a curve with respect to point. First, see what is the index of a curve. Suppose gamma is a if gamma is a closed rectifiable curve. Closed rectifiable curve means its length will be finite. Rectifiable curve in complex number system, and A be a point which is not belonging to trace of gamma, then the value of the integral, then the value of the integral one upon 2 pi I integral over the curve gamma dz upon z minus a is called index of a curve gamma of a curve gamma with respect to a point A, and it is denoted by and it is denoted by index of a curve, that is actually it is somewhat similar to our eta of a curve gamma around a point A or with respect to point A, and which is nothing but 1 upon 2 pi I integral over the curve gamma dz upon z minus a. So this one is nothing but the index of a curve with respect to a point. That is, if we have one curve that is gamma, which is a closed rectifiable curve, it means if suppose it is defined on closed interval AB, then gamma of A is nothing but gamma of B, and rectifiable curve means that length has a length of that curve will be finite, and there is a point A which is not belonging to trace of gamma, then the value of the integral 1 upon 2 pi I integral over the curve gamma dz upon z minus a is nothing but the index of a curve with respect to our point A, and it is denoted by this symbol, that is index of a curve gamma and with respect to a point A. And sometimes it is also called as a winding number of a curve gamma around a point A. Sometimes it is also called as a winding number of a curve gamma around a point A. Around a point A. And we know that 1 upon 2 pi I. In last lecture, we have already proved that 1 upon 2 pi and the value of the integral 1 upon 2 pi integral over the curve gamma dz upon z minus a is always
Integer.
integer. Therefore, the index of a curve gamma with respect to point A is always give a integer value. Okay. So, the index of a curve of a curve gamma around a point A A always gives integer value. Okay, since index of a curve gamma around a point A is nothing but the integral value of 1 upon 2 pi integration over the curve gamma dz upon z minus a, and in previous lecture we have proved that this one gives always a integer value. So our index of a curve gamma around a point A always gives an integer value. Now let us see what is the actual meaning of this index of a curve with respect to a point. Here actually we have to find out how many times our curve travels around a point A in clockwise or anti-clockwise direction. That is actually we have to find out the number of how many number of times the given curve travels around that point A. If it is in clockwise direction, then the value of that index will be negative, and if it is in clockwise anti-clockwise direction, then it must be positive. Okay. So the index of curve of a curve gamma around a point A is actually a number of times, the total number of times the total number of times a curve gamma travels around a point A. And A index is positive when it travels in anti-clockwise direction, and it is it is negative when it travels in clockwise direction. Okay, so what is the index of a curve around a point A? Just here we have to find out the number, how many times our given curve travels around that particular point, and if it is a travels in a clockwise direction, then it is negative, and if it is in anti-clockwise direction, then it must be positive. For example, if suppose there is a curve gamma, suppose this will be a curve, suppose this will be our curve gamma. Okay, now what is trace of gamma then? Trace of gamma is nothing but gamma of t.
T belongs to closed interval AB.
Where t is belonging to whatever will be our a. That is the definition of trace of gamma. Okay, actually trace of gamma, and gamma of t is nothing but gamma of t will be some w. That is w is belonging to this one. Then w is nothing but a plus r into e to the power it. That is w minus a is nothing but r into e to the power it. It means modulus of w minus a is nothing but r. That is, it is a circle which is centered at a and having radius will be r. So if this will be a curve, then trace of gamma will be all those points which are on the boundary of our given curve. Okay. Now Here we have to take AB any point. Suppose this will be a point A, and suppose it is in anticlockwise direction. Then what is its index around the point A? By definition, index of a curve means here we have to find out how many times our curve travels around a point A, and we have to take AB a point which is not belonging to trace of gamma, which is not belonging to trace of gamma. It means A is not on this boundary. Either A is belonging inside this curve or outside the curve. ओके, हे कळतंय का? ए मला ट्रेस ऑफ गॅमा मधून घ्यायचा नाहीये. ए हा ट्रेस ऑफ गॅमा मधून घ्यायचा नाहीये, याचा अर्थ या बाउंड्रीवरचा पॉईंट घ्यायचा नाही. म्हणजे कुठेही या बाउंड्रीवर माझा कर्व पॉईंट ए नसेल, एक तर बाउंड्रीच्या आतमध्ये असेल किंवा बाहेर असेल. जर तो आतमध्ये असेल तर आता याचा इंडेक्स किती असेल? अँटी क्लॉकवाईज मध्ये आहे का क्लॉकवाईज मध्ये आहे?
अँटी क्लॉकवाईज.
अँटी क्लॉकवाईज मध्ये असेल तर तो पॉझिटिव्ह 1 असेल. ठीक आहे का? याच ऐवजी जर समजा हा तू कर्व 2 वेळा फिरतोय समजा, now tell me what is the index of a curve gamma around a point A?
2.
2. If suppose this will be a curve gamma. Now what is the index of a curve gamma around a point A?
-1.
Which is -1. And what is the index of a curve gamma around a point B?
0.
0 असेल. फक्त तो त्या पॉइंटच्या अराउंड दिलेला कर्व किती वेळा फिरतो एवढं चेक करायचंय. जर फिरत असेल तर, जर तो अँटी क्लॉकवाईज डायरेक्शन असेल तर पॉझिटिव्ह घ्या, जर अँटी क्लॉकवाईज डायरेक्शन असेल तर निगेटिव्ह असेल. जर तो फिरतच नसेल त्याच्या अराउंड तर तो त्याचं इंडेक्स 0 येईल. आणखी इन जनरल जर एक्झाम मध्ये असा क्वेश्चन असेल की फक्त मला इंडेक्स कर्व दिला आहे, एक पॉइंट दिला आहे, पण तुम्हाला डायरेक्शन जर सांगितली नसेल तर ऑलवेज आपण डायरेक्शन ही अँटी क्लॉकवाईज कन्सिडर करायची. ठीक आहे. जर त्यांनी डायरेक्शन दिली तर ठीक आहे, त्यांनी जसं दिलंय तसंच घ्यायचं. जर त्यांनी डायरेक्शन दिली नाही तर आपण अँटी क्लॉकवाईज कन्सिडर करायचं ऑलवेज, जर डायरेक्शन दिलेली नसेल. ठीक आहे. याच्यावर इंडेक्स काढू शकता दिलेल्या कर्वचा?
येस सर.
ओके. नाउ देयर आर सम नोट्स. Let gamma from closed interval 0, 1 to C be a curve, then minus of gamma is also a curve from closed interval 0, 1 to C is also a curve, and it is defined by minus of gamma of t is nothing but gamma of 1 minus t, where t is belonging to closed interval 0, 1, and its value is nothing but, and index of a curve minus of gamma around a point A is nothing but minus of index of a curve gamma around a point. Okay, if we have one curve that is gamma which is defined from closed interval 0, 1 to C, then minus of gamma is also a curve which is also defined from closed interval 0, 1 to C, and it is defined by minus of gamma of t is nothing but gamma of 1 minus t, where t is lies between our given domain, that is closed interval 0, 1 to 1, and index of the curve negative of our given curve gamma around a point A is nothing but negative value of index of a curve gamma around a point A. And there is one more note which is nothing but if gamma and sigma, if gamma and sigma are the two closed rectifiable curves, are the two closed rectifiable curves, having same initial point, having same initial point A, then index of a curve gamma plus sigma around a point A is nothing but index of a curve gamma around a point A plus index of a curve sigma around a point A. For all A does not belong into curve gamma union curve sigma. Okay, it is not belonging to this curve, since by definition itself we have to take A be any point which is not belonging to trace of gamma. As this one is again a definition of index, therefore here we have to take a point which is not belonging to both the curve, that is it is neither belonging to this curve gamma or nor it is belonging to curve sigma. Similarly for this one also, negative of a given curve, it is also defined for A not belonging to curve gamma. Okay, so these are the two important notes. If suppose we have to find out the index of a curve, and that is summation of sum of two curves, and we have to find out its index with respect to a point A, then we have to find out the individually. First we have to find out index of a curve around a point A, that is index of a curve gamma around a point A, and we have to find out index of a curve sigma around point A, and if we take its sum, then we will get our required index of a sum of these two curves around a point A. Okay, now there is one lemma. Let gamma be a rectifiable curve, rectifiable curve, and suppose phi be a function defined and be a function defined and continuous on trace of gamma, on trace of gamma for each m greater equal by 1. For each m greater equal by 1, let us take fm of z as integral over the curve gamma I of w upon w minus z to the power m, w minus z to the power m dw, where z is not a member of trace of gamma, and also then show that each fm is each fm is analytic on C minus trace of a gamma, and Fm dash of Z is nothing but m into Fm plus 1 of Z. Okay, so here we have given one rectifiable curve, that is its length is finite, and there is one function phi which is defined and continuous on our trace of gamma. Then for each m greater equal by 1, there is one function defined fm of z which is equal to integral over the curve gamma phi of w divided by w minus z to the power m dw, where z is not a member of trace of gamma. Then we have to prove that each fm is analytic on C minus trace of gamma, which means for each value of m greater equal by 1, the given function fm is analytic on this domain, and fm dash of z is nothing but m into fm plus 1 of z. Okay, that is as it is. We have to prove that analytic means it is a continuously differentiable function. So if we prove our fm of z is continuously differentiable, then the given function fm is analytic function. Okay, and if it is analytic, then we have to prove that fm dash of z is nothing but m into fm plus 1 of z. Let us see the proof. Let gamma be a rectifiable curve, rectifiable curve, and phi is a continuous function on trace of gamma. Okay, now let us define, as we have to prove that Fm is analytic on C minus trace of gamma. We will take this C minus trace of gamma as a some G. Let G is nothing but C minus trace of gamma. And there is one function defined here, that is Fm. So let F is a function which is defined from G to C by Fm of Z, Fm of Z is nothing but integral over the curve gamma phi of W divided by W minus Z to the power m dw, where Z is not a member of trace of gamma. Now first tell me whether this given function is a well defined or not.
Yes, sir. Well defined.
Yes, since W is a member of trace of gamma, as W is a member of trace of gamma, then it must be of the form some gamma of t, that is a plus r into e to the power it. And Z is not a member of trace of gamma. As Z is not a member of trace of gamma, then Z cannot be expressed in this form, that is a plus r into e to the power it. Therefore, there is no possibility that W and Z must be equal. Okay, since they are belonging to two different sets. Z is belonging to trace of gamma, sorry, W is belonging to trace of gamma and Z is belonging to G. That is, G is nothing but C minus trace of gamma. Okay, as these 2 points are belonging to two different sets, then it is not possible that W must be equal to Z. Hence, the given function Fm is well defined. As Z is not belonging to trace of gamma, so Fm is well defined. And we know that trace of gamma is always closed and bounded. As it is always closed and bounded, then it must be compact. So trace of gamma is always compact, and also here we have given phi is continuous on this trace of gamma. Continuous on trace of gamma. Okay, now let us consider capital M as a supremum of modulus of phi of W. Since phi is continuous on trace of gamma, gamma is compact, always compact. As it is compact, then phi must be bounded. As phi is bounded, then we will consider capital M as a supremum of modulus of phi of W, where W is belonging to trace of a gamma, which implies modulus of phi of W is always less equal by this M. Is it true? करेक्ट आहे का हे?
Yes,
M ची
sir.
व्हॅल्यू सुप्रीमम ऑफ मॉड्युलस ऑफ फाय ऑफ डब्ल्यू आहे, तर मॉड्युलस ऑफ फाय ऑफ डब्ल्यू ची व्हॅल्यू ही ऑलवेज लेस इक्वल बाय एम असेल. जर हीच सुप्रीमम व्हॅल्यू असेल तर सेम असेल, otherwise it is always less than this one. Let us consider this one as a equation number 2, and the above equation is nothing but equation number 1. Okay, now we have to prove that Fm is analytic on G. To prove that function Fm is analytic on our G, that is C minus trace of gamma. Fm is analytic on G, that is C minus trace of gamma. That is, here we have to prove that function Fm is continuously differentiable on G. Okay, so what is continuously differentiable function? Any function is said to be continuously differentiable whenever, if suppose there is a function f, then when it is said to be continuously differentiable function.
If it is differentiable at each point in the domain.
And if it is differentiable at each
Continuous.
point in the domain, then it is differentiable. If it is differentiable, then it must be continuous ना.
Yes, sir.
म्हणजे प्रत्येक डिफरन्शिएबल फंक्शन हा कंटिन्युअसली डिफरन्शिएबल असतो का?
Yes, sir.
प्रत्येक फंक्शन कंटिन्युअसली डिफरन्शिएबल असतो. सपोज f is a function which is defined from closed interval 0 1 2 complex number system. Now, right here, whether this function is differentiable.
No, sir.
Why?
Log 0. Infinity.
If suppose this one is open, प्रत्येक डिफरन्शिएबल
Yes, sir.
फंक्शन हा कंटिन्युअस असतो का? प्रत्येक डिफरन्शिएबल फंक्शन कंटिन्युअस ऑब्वियसली. प्रत्येक डिफरन्शिएबल फंक्शन हा कंटिन्युअसली डिफरन्शिएबल असतो का?
No, sir.
वाय? मग कंटिन्युअसली डिफरन्शिएबलची डेफिनेशन तुम्ही जी सांगितली ती फक्त डिफरन्शिएबल झालं ना. त्याला कंटिन्युअसली डिफरन्शिएबल कधी म्हणतो आपण? आय थिंक ही डेफिनेशन मी लिहून दिली.
डेरिव्हेटिव्ह एक्झिस्ट व्हायला पाहिजे आणि ते स्वतः कंटिन्युअस असायला.
कोण फंक्शन का डेरिव्हेटिव्ह?
डेरिव्हेटिव्ह.
Derivative, yes. Any function f is said to be continuously differentiable if it is differentiable and its derivative is continuous. As here we have to prove that fm is continuously differentiable. It means we have to prove that fm is differentiable and whatever will be its derivative fm dash, that will be continuous. And if its derivative will be continuous, then we say that the corresponding function fm is continuously differentiable, and that is we have to prove. Okay. Now let a be any point in G, that is C minus trace of gamma. As A is belonging to G, that is C minus trace of gamma, it means it is not belonging to trace of gamma, that is A is not a member of trace of gamma. As A is not a member of trace of gamma, then what is the distance between A and trace of gamma, whether it is 0 or not 0? Not belonging to trace of gamma, that is belonging to G, and we have to find out the distance between these 2 points, that is any point on the trace of gamma and E. Then whether its distance will be 0 or not 0?
Non-zero.
तरी माझा C आहे. ओके, हा माझा C. ते कुठेतरी कर्व गॅमा आहे आणि ही तिचे ट्रेस ऑफ गॅमा. ओके, and इथे कुठेतरी समजा पॉइंट A आहे. A is a point which is not belonging to trace of gamma. Then its distance must be non-zero, that is will be equal to some r, and which is greater than 0. Then for each point Z belonging to G, we have for each epsilon greater than 0, there exists some delta greater than 0, for which modulus of Z minus A is less than delta, where delta will be some small quantity, that is we will consider here that will be less than our r by 2. Okay, so for each epsilon greater than 0, we can choose a delta greater than 0, choose a delta greater than 0 such that modulus of Z minus A is less than delta. Since A is not a point which is not belonging to trace of gamma, Z is also a point which is belonging to G, it means it is also belonging to trace of gamma. Since already we have given Z is not belonging to trace of gamma, therefore Z and A both are the points which are not belonging to trace of gamma, and distance between A and trace of gamma will be r. Then distance between these 2 points which are not belonging to trace of gamma must be less than delta, where this delta we can choose small quantity. So here we will take some r by 2. Okay, now from that one we will consider modulus of fm of Z minus fm of A. fm of A. But by definition itself, what is fm of Z? Fm of z is nothing but integral over the curve gamma phi of w divided by w minus z to the power m dw minus fm of e. Instead of z, we have to replace it by e. Integral over the curve gamma phi of w divided by w minus e to the power m dw. Okay, as phi of w is common in both the integral, therefore it one is nothing but integral over the curve gamma, sorry, modulus of integral over the curve gamma phi of w into 1 upon w minus z to the power m minus of 1 upon w minus a to the power m dw. Again, we know that modulus of integration is less equal by integration of modulus. So this quantity will be less equal by integral over the curve gamma modulus of phi of w into 1 upon w minus z to the power m minus of 1 upon w minus a to the power m dw. Okay, that is, it can be written as integral over the curve gamma modulus of phi of w into modulus of 1 upon w minus z to the power m minus 1 upon w minus a to the power m modulus of dw. Okay, so this one is nothing but actually our modulus of fm of z minus fm of a. So it is nothing but fm z minus of fm of, okay, and which is less equal by integral over the curve gamma modulus of phi of w into modulus of 1 upon w minus z to the power m minus 1 upon w minus a to the power m into modulus of dw. Let us take this one as some equation number 4. Okay, now there is one formula that is which is called as a factorization formula. Factorization, and which is nothing but 1 upon x to the power n minus of 1 upon a to the power n can be written as 1 upon x minus of 1 upon a into summation k running from 1 to n 1 upon x to the power 1 upon x to the power n minus k into a to the power k minus 1. Okay, so this will be a in general formula, that is if we have two value, that is x and e, then 1 upon x to the power n minus 1 upon a to the power n, it can be written as 1 upon x minus 1 upon a into summation k running from 1 to n 1 upon x to the power n minus k into a to the power k minus 1. Now we have to use that formula for these values. So here consider modulus of 1 upon w minus z to the power m minus 1 upon w minus a to the power m, which is equal to, what is the value of this one by using this formula? Is nothing but 1 upon x minus 1 upon a. Here x is nothing but w minus z, a is nothing but w minus a, then it is nothing but 1 upon w minus z minus 1 upon w minus a into modulus of summation k running from 1 to n. Here n is nothing but m 1 upon w minus z to the power n minus k, which is m minus of k into a to the power k minus 1. A is nothing but w minus a. So w minus a to the power k minus 1. कुणाला काही डाऊट यामध्ये?
No, sir.
B. Now, which is equal to, solve this one, which is actually nothing but w minus a minus of w minus z. Minus w plus w gets cancelled. Then we get z minus a, so which is nothing but z minus a divided by w minus z into w minus a into summation k running from 1 to m 1 upon w minus z to the power m minus k into w minus a to the power k minus. Okay, now as it is a multiplication, then take these two terms, that is w minus z and w minus a inside our sum. then we get modulus of z minus a into summation k running from 1 to m 1 upon w minus z to the power m minus k into w minus z, which is nothing but w minus z to the power m minus k plus 1, w minus z to the power m minus of k plus 1 into w minus a to the power k minus 1 plus 1, plus 1 minus 1 cancel, which is plus a. Okay, so let us take this one as some equation number 5, and this will be a value of 1 upon w minus z to the power m minus 1 upon w minus a to the power m. Okay, now as r is nothing but the distance between 2 points a and trace of gamma, that is actually it is nothing but infimum of distance, means it is the infimum distance between these 2 points, so it is nothing but infimum of distance between a and w, where w is belonging to trace of gamma. But what is the distance, which is nothing but the modulus of w minus a, that is nothing but infimum of modulus of w minus a, where w is belonging to trace of gamma. Okay, now here r is nothing but the infimum value of w minus a. Then what is the relation between r and w minus a?
Less.
Infimum value of modulus of w minus a is equal to r. Then what is the relation between these two values, that is modulus of w minus a and r? Whether modulus of w minus a is less equal by r or it is greater equal by r. इक्वल आहे इन्फिमम व्हॅल्यूला, सगळ्यात लहान व्हॅल्यूला तो इक्वल आहे, तर बाकीच्या व्हॅल्यूला काय असेल तो
Greater.
एक तर मोठा असेल किंवा त्याच्या इक्वल असेल. It means modulus of w minus a is always greater equal by r. As it is greater equal by r, then it must be strictly greater than r by 2. And z is not a point of trace of gamma, and w is a point of trace of gamma. Then what is the distance between modulus of w minus w and z? Z is a point which is not in trace of gamma, w is a point which is belonging to trace of gamma. Then what is the distance between these 2 points w and z? Whether it is greater than r by 2 or less than r by 2. Let's see how. Okay, suppose this will be a modulus of w minus z. We can write this one as a w minus a plus a minus z. Okay, so we will write this one as, which is nothing but modulus of w minus a minus of z minus a. Correct type? Now, what is the relation between modulus of z1 minus z2 and mod z1 minus mod z2?
Greater equal.
Modulus of z1 minus z2 is always greater equal by modulus of z1 minus modulus z2. It means it is greater equal by modulus of w minus a minus modulus of z minus. Okay, now what is the value of modulus of w minus a? Modulus of w minus a is always greater equal by this r, always greater equal by this r, and this quantity modulus of w minus z is greater equal by this modulus of w minus a. Modulus of w minus a is greater equal by r. It means here we will replace the smaller value. Then whether there is any त्या इनइक्वालिटीवर काही फरक पडेल का? मॉड्युलस ऑफ w मायनस z हा ग्रेटर इक्वल आहे या दोन्हीला. मी आणखीन w मायनस a हा माझा लेस ग्रेटर इक्वल आहे r ला. जर मी w मायनस a च्या ऐवजी जर r ने याला रिप्लेस केलो तर इनइक्वालिटीवर काही फरक पडेल की आहे तशीच राहील?
आहे अशी राहील.
लहान क्वांटिटीने रिप्लेस केला तर ऑलरेडी ते जे व्हॅल्यू आहे त्याच्यापेक्षा तो मोठा आहे. त्याच्यापेक्षा लहान व्हॅल्यू जर तुम्ही रिप्लेस केला आणि त्यातून तुम्ही मॉड्युलस ऑफ z मायनस a जर तुम्ही सबट्रॅक्ट करत असेल तर ऑलरेडी जी इनइक्वालिटी आहे ती आहे तशी राहील, विच इज ग्रेटर इक्वल बाय r minus. Now modulus of z minus a, here somewhere we have taken modulus of z minus a which is less than this r by 2. Modulus of z minus a is less than r by 2. So whenever we replace this value by r by 2, then what is the effect on its inequality? Inequality वर काय फरक होईल? डब्ल्यू मायनस ए हा आर किंवा आर पेक्षा मोठा आहे. आरने जर मी त्याला रिप्लेस केलो तर ती इनइक्वालिटी आहे तशी राहील. जर तो इक्वल असेल आरलाच तर आहे तशी राहील. आणखी जर आर हा याच्यापेक्षाही लहान असेल तर तो इनइक्वालिटी काय होईल, स्ट्रिक्टली लहान होईल. म्हणजे मी ही पॉसिबिलिटी अज्युम केलो की तो इक्वलच आहे आरला. जर स्ट्रिक्टली असेल तर इथंच माझं प्रूफ होईल. स्ट्रिक्टली असेल तर ऑब्व्हियसली याच्यापेक्षाही तो स्ट्रिक्टलीच असेल. पण इफ पॉसिबल इफ सपोज इट इज ग्रेटर इक्वल अँड मॉड्युलस ऑफ डब्ल्यू मॉड्युलस ऑफ झेड मायनस ए इज लेस दॅन आर बाय टू. आर बाय टू आहे किंवा आर स्ट्रिक्टली लेस दॅन आर बाय टू असेल तर ही इनइक्वालिटी चेंज होईल. ठीक आहे का?
Yes, sir.
मॉड्युलस ऑफ डब्ल्यू मायनस ए हा ग्रेटर इक्वल बाय आर आहे. तो जर रिप्लेस केला तर तो ग्रेटर इक्वल आहे तसा राहील. परंतु त्यातून जर मी आर बाय टू ही व्हॅल्यू जर रिप्लेस केली म्हणजे मॉड्युलस ऑफ झेड मायनस ए काय आहे माझं, लेस दॅन आर बाय टू आहे. ही व्हॅल्यू जर मी यातून सबट्रॅक्ट केली तर ऑब्व्हियसली ही स्ट्रिक्टली ग्रेटर दॅन होईल. सो मॉड्युलस ऑफ डब्ल्यू मायनस झेड इज स्ट्रिक्टली ग्रेटर दॅन आर बाय टू. ओके. सो मॉड्युलस ऑफ डब्ल्यू मायनस झेड इज ग्रेटर दॅन आर बाय टू. Okay. Now, put this equation number 5 in our equation number 3. Here we have to put this value. Sorry. In equation number 4 we have to put. Okay. Put equation 5 in equation 4. We get modulus of Fm of Z minus Fm of A is less equal by, or sorry, it is equal to, I think fourth one will be, here we have to put this value in this one. So it is less equal by integral over the curve gamma modulus of Z minus A. We are replacing the value. What is equation 5? Modulus of Z minus A. And what is equation number 4? Integral over the curve gamma modulus of phi of W into this one. So here integral over the curve gamma phi of W into this value now. 1 upon W minus Z to the power M minus 1 upon W minus A to the power M. That one is nothing but modulus of Z minus A into summation K running from 1 to M 1 upon W minus Z to the power M minus K plus 1. Actually it is nothing but modulus of this one. But modulus of this one is nothing but to the power M minus of K plus 1 into W minus A to the power K into its modulus into modulus of dW. Okay, that is, it can be written as integral over the curve gamma modulus of phi of W into modulus of Z minus A into summation K running from 1 to infinity. This modulus can be written as 1 upon modulus of W minus Z to the power M minus K plus 1 into modulus of W minus A to the power K into modulus of dW. Now just we have to put the values, which is less equal by integral over the curve gamma. Modulus of phi of W is less equal by M. Since phi of W is bounded by M, so it is less equal by M. Modulus of Z minus A is less than delta summation K running from 1 to infinity 1 upon W minus Z. W minus Z is modulus of W minus Z is always greater than R by 2. So which is R by 2 to the power M minus of K plus 1 into W minus A to the power K. Modulus of W minus A is strictly greater than R by 2. So it is R by 2 to the power K into modulus of dW. ओके, यामध्ये कोणाला काय डाऊट? मॉड्युलस ऑफ डब्ल्यू मायनस झेड हा ग्रेटर दॅन आर आहे, परंतु तुम्ही इनइक्वालिटीवर काही चेंज केलं नाही असं काही. मॉड्युलस ऑफ डब्ल्यू मायनस ए इज स्ट्रिक्टली ग्रेटर दॅन आर बाय 2 अँड मॉड्युलस ऑफ डब्ल्यू मायनस झेड इज ऑल्सो greater than r by 2. Okay, but 1 upon w minus a. What is the relation between this one now? 1 upon r by 2. इनइक्वालिटी रिव्हर्स होईल. आपण व्हॅल्यू 1 अपॉन डब्ल्यू मायनस झेड ची पुट केली इथं. ठीक आहे का?
Yes, sir.
Okay, so which is nothing but this one. So which is less equal by, take all the constant terms outside the integration m delta. This will be also constant. That is, it is actually nothing but summation k running from 1 to infinity 1 upon r upon 2 to the power m minus k plus 1 plus k minus k cancel, which is m plus 1 into modulus of dw. And here somewhere we have our integration as it is. Okay, so which can be written as m into delta. This r by 2 to the power m plus 1 is nothing but 2 by r to the power m plus 1, and integral over the curve gamma of summation k running from 1 to m modulus of dw. First we have to find out the summation. Okay, actually summation of modulus of dw means it is something 1 into modulus of dw. Now what is the summation k running from 1 to m of 1, which is m? We have to add
Yeah.
1 m times, which is m. So which is nothing but m into small m into delta 2 by r to the power m plus 1 into integral over the curve gamma modulus of dw. Now, as gamma is a rectifiable curve, it means its length is finite. As gamma is a rectifiable curve, then its length is finite. Therefore, integral over the curve gamma modulus of dw will be equal to some capital M. So, which implies modulus of fmz minus fma is less equal by this value, capital M into small m into delta 2 by r to the power m plus 1 into, yeah, let us take this one as some equation number 6. Okay, actually we have to show that fm is continuous. That is, we have to show that modulus of fmz minus fma is less than some epsilon for modulus of z minus a is less than delta. But here we get modulus of fmz minus fm of a is less equal by this quantity. Okay, now we will choose our delta as, we can choose delta as minimum of two values, since already we have taken modulus of z minus a is less than delta and which is less than r by 2. So here there are two possibilities for delta. That is, it is nothing but minimum of r by 2 comma epsilon into r by 2 to the power m plus 1 divided by capital M into small m into m. Okay, so here we have taken delta as a minimum of these two, that is either r by 2 or epsilon into r by 2 to the power m plus 1 divided by capital M into small m into m. Then, which implies for each epsilon greater than 0, which implies for every epsilon greater than 0, there exists a delta greater than 0 such that modulus of fmz minus fma is less than epsilon whenever modulus of z minus a is less than delta. हे कसं येईल चेक करा. जर दोघांच्या मिनिमम मध्ये जर r बाय 2 असेल, r बाय 2 जर असेल म्हणजे डेल्टा हा r बाय 2 पेक्षाही लहान असेल, तर ऑब्विसली तो याच्यापेक्षाही लहान असेल. ठीक आहे का?
Yes, sir.
r बाय 2 पेक्षा लहान आहे याचा अर्थ याच्यापेक्षाही लहान असेल. म्हणजे r बाय 2 च्या ऐवजी जर तुम्ही ही व्हॅल्यू इथं जर रिप्लेस केला तर काय होईल माझं, हा r बाय 2 टू दी पॉवर m प्लस 1 याच्याशी कॅन्सल होईल. कॅपिटल एम स्मॉल एम एल कॅन्सल होईल, राहील काय फक्त ऍप्सिलॉन. आणि जर ऑब्विसली जर डेल्टा इक्वल टू याच्यात असेल तर मात्र मी रिप्लेस करू शकतो. जर मिनिमम व्हॅल्यू r बाय 2 असेल तरी मी जर ही रिप्लेस केलं तर ही इनइक्वालिटी ऍज इट इज राहील. ठीक आहे का?
Yes, sir.
ओके, काही का असेल ना डेल्टाची व्हॅल्यू r बाय 2 जरी असेल आणि मी याच्याने रिप्लेस केले तर इनइक्वालिटी आहे तसंच राहील. आणि जर डेल्टा याच्या इक्वलच असेल तर काही प्रॉब्लेमच नाही. ओके, सो इन बोथ द कंडिशन्स मॉड्युलस ऑफ fmz minus fm of a is less than epsilon whenever modulus of z minus a is less than delta. Then by the definition of continuity, which implies our given function fm is continuous at a point sum a, continuous at a point a. But here we have chosen this point A is any arbitrary point belonging to our given domain, that is z minus trace of gamma. Therefore, as it is true for any arbitrary point, then it must be true for any point in our given domain, which implies fm is continuous on given G, that is C minus trace of gamma. So here our half part will be covered. Now the next one is nothing but we have to show that fm is different, continuously differentiable. It means here we have to show that fm is differentiable and its derivative will be continuous. Now we have to prove that fm dash of z is nothing but m into fm plus 1 of z. Then we say that fm dash is continuous. Fm is differentiable. And if we prove our fm plus 1 is also continuous, then fm is continuously differentiable on our given domain, and from that one we will say given function will be analytic. Okay, now consider fm of z, just consider fm of z, fm of z minus fm of e, and which is equal to integral over the curve gamma phi of w divided by w minus z to the power m into dw minus integral over the curve gamma phi of w divided by w minus e to the power m dw. And we have solved this one. By solving this one, we will get integral over the curve gamma phi of w into z minus a into summation k running from 1 to m 1 upon w minus z to the power m minus of k plus 1 into w minus a to the power k and into dw. Here we will write dw as it is. Okay. Now, as z is a point which is not belonging to trace of gamma, a is also a point which is not belonging to trace of gamma. So as z is tending towards c, then we have to divide both sides by z minus a. So we get here, just we have to consider fm of z minus fm of. There is no need to take modulus. So fm of z minus of fm of a divided by z minus a is equal to integral over the curve gamma phi of w into summation k running from. We will take this phi of w inside the sum. Then we will get summation k running from 1 to m phi of w divided by w minus z to the power m minus k plus 1 into w minus a to the power k into dw. Now we have to check whether this function that is inside the sum will be well defined or not. Okay, now as given that phi is continuous on trace of gamma and a is a point not belonging to trace of gamma, z is a point which is not belonging to trace of gamma, and w is a point which is belonging to trace of gamma. Now tell me whether this function, that is this one, will be well defined or not. प्रॉब्लेम कुठं आहे, जिथं जिथं डब्ल्यू हा झेड आणि ए च्या इक्वल होईल, पण झेड आणि ए असे पॉइंट आहेत जे की ट्रेस ऑफ गॅमा मध्ये नाही आहेत आणि डब्ल्यू हा पॉइंट आहे ट्रेस ऑफ गॅमा मधला, म्हणजे ती पॉसिबिलिटी आहे का कुठं?
No, sir.
It means it will be well defined. So the quantity phi of w divided by w minus z to the power m minus of k plus 1 into w minus a to the power k is well defined. As it is well defined and phi is a continuous function on trace of gamma, then this whole quantity is well defined and continuous on trace of gamma. Is well defined and continuous on, since it works as just a constant, continuous on trace of gamma. Okay, now taking the limit as z tending to a towards both side of this equation number 7. Taking limit z tending to a on both sides, then we get limit z tending towards a fm of z minus of fm of a, and which is equal to limit z tending to a, limit z tending towards a, integral over the curve gamma summation k running from 1 to m phi of w divided by w minus z to the power m minus of k plus 1 into w minus a to the power k and into dw. Okay, now as z is tending towards in a, then replace this z by a, then integral over the curve gamma summation k running from 1 to m phi of w divided by w minus a to the power m minus of k plus 1 into w minus a to the power k into dw. So which is actually nothing but integral over the curve gamma summation k running from 1 to m phi of w divided by w minus a to the power m minus k plus 1 into w minus a to the power k, which is nothing but plus k minus k cancel, w minus a to the power m plus 1 into dw. Okay, so which is nothing but integral over the curve gamma, as sum is running over k, so which is nothing but phi of w divided by w minus a to the power m plus 1 into dw and into summation k running from 1 to m into 1. What is this summation?
M.
Which is nothing but m into integral over the curve gamma. By the definition of fm, what is this phi of w upon w minus a to the power m plus 1 dw?
Fm plus 1.
Which is nothing but fm plus 1. fm plus 1. So here fm is nothing but, sorry, fm dash, sorry, left hand side will be nothing but limit z tending towards a fm of z to fm of z minus fm of a divided by z minus a. And what is this quantity LHS? Limit z tending to a fm z minus fm of a divided by z minus a. By definition of
Derivative of
derivative,
Fm
it is
minus
nothing
Z.
but derivative of fm, that is fm dash, and which is equal to m into fm plus 1. Actually here also we can write fm dash. Here there is a term z minus a. Okay. So this will be nothing but fm dash, and which is equal to m into fm plus 1. But which is at a point a. So fm dash of a is nothing but m into fm plus 1 of a. But we have chosen a is any arbitrary point in z minus, sorry, g minus trace of gamma. But a is arbitrary point in g. A is arbitrary point in g, that is c minus trace of gamma. It means fm is differentiable in whole g, differentiable on whole g, that is fm dash of z is equal to m into fm plus 1 of z for all z belonging to our g. So here fm is a differentiable function on a g. Now we have to check whether its derivative will be continuous. fm plus 1, as we have proved that fm is continuous, then fm plus 1 is also continuous by same way. असेल का?
Yes. Yes, sir.
Since fm plus 1 is continuous, fm plus 1 is continuous. So here fm is differentiable function on g, fm plus 1 is continuous on g, which implies fm is continuously differentiable on set g. As it is continuously differentiable on g, then by the property of analytic function, fm is analytic on g. So here we get fm is a function which is defined by integral over the curve gamma phi of w upon w minus z to the power m dw, which is differentiable, and its derivative is nothing but fm dash of z will be equal to m into fm plus 1 of z, and it is analytic on a whole set G. Okay, and that is we have to prove, and hence the required. Yes, कुणाल काही डाऊट? एक थेरम
No,
मोठा
sir.
आहे, परंतु इतकं काही कन्स्ट्रक्शन करायचे आहे.